All right, guys, so we're going to work more on surface area and volume of pyramids. These can be a little trickier, but some of them are similar. So we're going to look at the first two on the notes today. Tomorrow in class, we'll look at 3 and 4 that are on the back page. So let's start with number 1. It says a regular triangular pyramid below has a slant height of 20 centimeters and a base edge of 24 square roots of 3 centimeters. Find the lateral area, total area, and volume. So first, let's remember the equations. Lateral area is 1/2 of the perimeter of the base times the slant height. Total area, 1/2 PL again, but this time you're going to add the area of the base. And then volume, and don't forget this part, is 1/3 big B times H. So we need to find 4 variables. I need P, the perimeter, L, the slant height, H, the actual height, and big B, the area of the base. So that's what we're going to find. We're going to have to draw a few pictures here, but some of them are pretty easy to find. So it says first in the problem that it has a slant height of 20 centimeters. So this line right here is 20 centimeters. That's our L, so I'm going to go ahead and write it right here. It also tells me that each base edge is 24 square roots of 3. Now I can find the perimeter by multiplying that times 3. I got the perimeter to be 72 square roots of 3. Now that leaves us with H and B, and those are going to kind of be the tough ones. Remember, big B is the area of the base. So I'm going to come over here. I'm going to draw the base, and I'm going to go ahead and write on it 24 square roots of 3 for the side length, okay? I'm also going to draw that slice because I need to find the height, and I know it's right there, okay? So the things I know about that slice, though, are that this is 20. Now, if I can find the apothem on this triangle, then I have the base of my slice. So half of 24 square roots of 3 is 12 square roots of 3, which makes the apothem 12. Now I know that this base is 12, and I can find the height. So I have H squared plus 12 squared equals 20 squared. And if you start working that out, you get H is 16. Now, it's a triangle, and we need to find the area of this base right here. And normally I'd say, 1/2 base times height. But we don't have the height of the actual triangular base. We would have to find all this right here, and that might be a little bit complicated. But what we do know is that we can also find area with 1/2 of the apothem times the perimeter, and we do have both of those. So that's how I'm going to find big B this time. That's 1/2 of 12 times the big P we found earlier, which it looks like is 72 square roots of 3. Now be careful when you do this. Half of 12 would make that 6 basically. 6 times 72 square roots of 3 gives me 432 square roots of 3. And that's really big, but that's okay. So big B, 432 square roots of 3. Now that's the hardest part of the whole problem. Everything else is pretty quick. So we're going to find lateral surface area first. That's 1/2 PL, so 1/2 of the perimeter times the slant height. And of course, you can do this in whatever order you want to. Once you put that in your calculator or figure it out, I got 720 square roots of 3, and that would be centimeters squared. Total area. Now, people are having trouble with this. This half is already used when we get that number, and that's what we have to start off with 1/2 PL. So 720 square roots of 3, but we're going to add to that the value of B, 432 square roots of 3. When I add up these two numbers, since they both have square roots of 3, I got 1,152 square roots of 3 centimeters squared. And then the last one is volume. I guess I'll come up here. Volume is what people mess up on the most because they forget to put in this 1/3 big B, 432 square roots of 3, times the height, 16. Now be very careful when you put this in. It's a pretty big number. I got 2,304 square roots of 3 centimeters cubed. So be careful when you're finding those missing pieces. I mean, this is really the tough stuff. If you can do that, everything else is just plugging it in. Let's look at the second problem real quick. It's basically the exact same problem, so you might try to do a little bit of it yourself before you get into it. I'm going to go ahead and start, though. It says a regular triangular pyramid below has a base edge of 32 square roots of 3. and a slant height of 34 centimeters. So it gave us pretty much the same stuff. It says find the lateral, total area, and volume. So let's go ahead and label out. We need perimeter of the base. We need slant height. We can go ahead and find both of those. Slant height was 34. The perimeter, I have 32 square roots of 3 times 3 gives me 96 square roots of 3. So we got both of those. Now what's a little tougher is we need to find the height and we need to find the area of the base. So same thing I did last time. I'm going to go ahead and draw the base and what I know about it. Let's see, 32 square roots of 3. And then I'm going to draw my slice as well because I don't know what h is, but I do know the hypotenuse is 34. So again, if I can find that line right there, the apothem, I can use that to find the area of the base and use it to find the height. So if the side length's 32 square roots of 3, this half is 16 square roots of 3, which makes the apothem 16. That makes this base 16. Now I can use Pythagorean theorem. H squared plus 16 squared equals 34 squared, which would give you h squared equals 900 when you did the work. So h is 30. Go ahead and fill that in. Now, the same thing happens as last time. I could use 1/2 base times height, but I know that any regular polygon can also be found with 1/2 AP. So I'm going to use that to find big B again, since we have those. That's 1/2 times 16 times 96 square roots of 3. If I work that down, I ended up getting 768. It's a big old number, square roots of 3 for my big B. So 768 square roots of 3. So again, once you get that stuff done, everything's pretty easy. So let's do lateral area first. That'd be 1/2 of the perimeter, 96 square roots of 3, times the slant height L, 34. When I plug that into my calculator, I got 1,632 square roots of 3 centimeters squared. The total area, I'm going to take that, I'm going to write that first, sorry. I'm going to take that lateral area, I'm going to add to it the area of the base. Since they both have square root of 3, I can add them together. I got exactly 2,400 square roots of 3 centimeters squared. The last one, the volume, that's 1/3 of big B times the height, which we found was 30. If you plug that in your calculator, you get an enormous number. It would be 7,680 square roots of 3 centimeters cubed. Okay, so those are really similar problems. There's some that are just like that on your homework. Draw your base, draw your slice, because if you get it wrong and I see all that stuff, it makes me think that you tried. Now on the next page, these are the ones we're going to do at the beginning of class. It's the same basic questions. The only difference is here, and I really want to make sure you know this, they still told us the base edges are 16, but now they're not giving us slant height or height. They're giving us a lateral edge. So guys, the lateral edges go from the vertex down to the corners. Okay, this is not slant height. They gave us 2 square roots of 41 for this one. So you can find perimeter pretty easy. You can even find area of the base pretty simply. It's going to be the height and the lateral height that we have to, that's kind of tough, or I'm sorry, the slant height. So if you want to try these out, that's great. I'll go ahead and tell you if you want to. That would be 320 inches squared. This one would be 576 inches squared. And then we'd have 512 inches cubed for the volume. And so feel free to do that if you want to. The last one, just be careful because remember the base is a hexagon. So when you're finding the apothem, it's a 30, 60, 90. So you might just realize that that's the x squared of 3 side, that's the x side, that's the 2x. So be careful if you try those out. Good luck, and I will see you tomorrow.